Students, do this division. 117 divided by 5. How many digits outside? Only one digit, sir. So let us take one digit inside. In the dividend, let us take one digit, as because in the divisor there is only one digit. But after taking the number of digits inside the divisor, we must dividend. We must remember that the dividend must always be greater than the divisor. But here, after taking one digit, we see that the digit 1 is smaller than the digit 5. That means the dividend is smaller than the divisor. So in order to make it bigger, the dividend always should be bigger than the divisor. So we have to take two digits now. So 5 2s are 10. Remainder 1. We have written 1, but this is no more the remainder. This is dividend. Why, sir? Because see, there it is not yet finished. There is another digit upstairs in the question, in the divisor. I'm sorry, dividend. So dividend should always be greater than the divisor. So here we can see that 1 is smaller than 5. So 7 has to be brought down. Now 17 has become bigger than 5, means dividend has become bigger than the divisor. So therefore 5 3s are 15. Now 2. Is there any more digit to be brought down? No. So that means the division is finished. And this is the remainder now. No more dividend it will be called. Because there is nothing else to be brought down. So it is the remainder. It is the quotient. It is the dividend. And it is the divisor. Sir, this we have already learned in class 5. Rather, we have started learning this division right from class 4. Maybe in class 4 there was no remainder. In class 5 onwards we got a remainder. But you are forgetting, sir, we are in class 10 now. Very correct, students. You are in class 10. But you know, I have some purpose behind this. The purpose is nothing else that I am going to explain you Euclid's division lemma. So, good evening, students. Welcome to Students Accuracy in Demands class. I am going to explain you this topic, Euclid's division lemma today. You must understand this. For that, you should not skip this video, must watch this video from beginning to the end. Okay? And if you like, please press the like button and press the bell icon so that whenever I'll post the next video, you'll get quicker than others. And of course, please don't forget to press the subscribe button. Next, we are going to learn Euclid's division lemma. Sir, big name you have given, it is given, but we can't understand what is lemma. Euclid I can understand, mathematician. Division, we can understand this division. And lemma, what is lemma? Lemma is nothing but a statement that requires no more proof. And the statement that is that helps in proving some other statements. That is called as lemma. So we have understood lemma. Now his lemma says, Euclid's division lemma says, for any two given positive integers a and b, there exists unique whole numbers q and r. सर टेंजेंट होकर निकल गया, कुछ तो बोलेंगे सर 6 इंच ऊपर से निकल गया. करेक्ट, डोंट वरी, आई एम हियर, मैं हूं ना. सी, before we understand the whole thing, let us understand the terms used in this. The first term is positive integers. Now, what do we mean by integers? Integers are those numbers which can be plotted on a number line. Yes or no? So, let us forget about 0 and the negative side. positive side. They are talking about positive integers. So let us ignore negative, let us ignore 0, let us take the positive integers. So you have understood positive integers. What are they? Now A and B. Unique whole numbers. So another term is unique. So what do we mean by unique? Now unique means something that is alone, that is one on earth. There is no second thing similar to or equal to the particular thing. Like every whole number, every real number is a unique number. Is there second one? Is there second 2? Is there second 9? Is there second 100? Is there second you? Is there second me? Sir, क्या बोलते हैं sir? We may have twins. No. Even though the twins are there, but still their personality, their characters, their fingerprints, their retina, plus other parameters, definitely this or that will prove the individuality of you or individuality of me. So each one of us are unique. Each and every real number is a unique number. Individuality, uniqueness, one number. Okay? So unique whole numbers. What do we mean by whole numbers? All numbers up to infinity from 0. Whole numbers. So for any two given positive integers A and B, there exists unique whole numbers Q and R. Let us see this here. The dividend is equal to divisor into quotient, let us take small q, plus small r, remainder. Up to class 4 we had such numbers where there was no remainder. Up to class, after class 4, when we came to class 5, remainder came into the picture. Now see here, my dear students, dividend is equal to divisor into quotient plus remainder. Now in place of dividend, see, dividend, divisor, this is divisor, quotient, remainder 2. See, divisor is how much? 5. Quotient 23. Remainder 2. See, 5 3s are 15, carry 1, 5 2s are 10, 11 plus 2 is how much? 1. So Euclid says A, that means the dividend, is equal to divisor B into quotient BQ plus remainder. Am I clear? A is equal to BQ plus R. Now, while explaining this division, I was telling you that the dividend should not be less than the divisor. So, naturally, here, instead of 2, if it was 6, would you say that 6 would be the remainder? No. The moment you will see that this number or any other number here which is coming as remainder at the end is bigger than the divisor, you will definitely divide it. Suppose if this becomes 6, you will say 5, ones are 5 and remainder will become 1. Anyhow, remember, this remainder has to be less than the divisor. Okay, now this remainder therefore can be more than or equal, less than or equal to 0. I'm sorry, remainder should be greater than, remainder should be greater than equal to 0 and less than divisor. Remainder has to be greater than equal to 0. Means, suppose I divide 9 by 4. 4 2s are 8. 1. But if I divide 8 by 4, 2s are 8. Here the remainder is 0. So see, remainder can be 0. Remainder should be greater than or equal to 0. Remainder is 1 greater than 0 or equal to 0. So remainder will never be less than 0. If it is negative, obviously it will become less, so that cannot be. Therefore we have taken positive, not negative. Now remainder should be greater than equal to 0, but this remainder should always be less than divisor. If it becomes 5, as I told, if it becomes 6, you will say 1, 5 ones are 5, it will become small. Always remember, if it becomes 5, 4 ones are 4, remainder 1. Am I clear? Up till here, this is nothing. Our basic concept is this one, which we have learned. We have been learning from class 4 onwards or 5 onwards. The new thing we are learning here is this. Okay? This also will become very clear to you when we will start solving certain examples. Okay? So students, please note it down. I am coming back with the question. Pause the video and note it down, because definitely questions may be asked from here also, whatever I have explained. Clear? So note it down, pause the video and note it down. I am coming with the further example. Now students, see, this is the example. Show that every positive even integer is of the form 2q, and that every positive odd integer is in the form of 2q plus 1 for some integer q. Means positive even 2q, positive odd 2q plus 1. So now, solution, see students. Let A be the positive integer. Now in this, when A is the positive integer, A has to be equal to 2q plus, as in the form A is equal to BQ, so B is 2 and what is R? 0 here. So here, as per this theorem, where R should be equal to how much? It may be 0. Why? Because they are telling BQ plus R, means R should be greater than equal to 0. I mean, it may be equal to 0 and greater than 0, maybe 1, maybe 2. No, it will be only 0 and 1. Probability or possibility of 1 R can be 0 and 1 in this equation. Why? It cannot be 2. Why? Because they are telling R should be less than B. What is B here? BQ. B is 2. So R should be less than 2. So it cannot be 2. So remainder should be 0 or 1. But if it is an even integer and if it is divided by 2, there cannot be any divisor, means remainder. 1 also therefore rejected. So therefore no 0 plus 0 means only the same thing. It is divisible by 2, hence it is even. So A is equal to even, positive even integer for Q. Okay, next. See, let us take, suppose 8 divided by 2. 8 is divisible by 2. 2 4s are 8, 0. It is 0. So 2 into Q. 2 into Q plus remainder. That means 2 here into 4 plus remainder 0 equals to 8. the dividend we are getting back. So, therefore, it is an even. Why? Because remainder can be 0, 1. Cannot be 2 because B is 2. R should be less than B. So, 2 it should be less than 2, 0, 1. Clear? So, therefore, A is even. Now, let again A is equal to, as per this, 2Q plus 1. Now, here, what we find? R should be less than equal to 0. So, it will be, it may be 0. R is given 1, of course, equal to 1. It is already given. It is already given. This is R. This is nothing else but R. R is 1 here. So, R is 1. So, that means some number that is divisible by 2. But along with that, if we are adding 1 to that number, it can never be an even number. It has to be an odd number. Therefore, it is odd. Clear, students? Because it cannot be 0. 0 is not given. But it should be less than 2 also. So, it is 1. So, that means R is 1. 1 is exactly present here in this equation. We cannot ignore R as 1 here. So, therefore, it is not an even number. It is an odd number. Clear, students? Please copy it down. Let's go for the second example. Pause it and copy it down. Now, students, solution. Let A be the positive integer. We are not talking about odd or even. That we have to prove. So, Q be the quotient and R be the remainder. Okay, now here what we find in case of this, see, A is equal to 4Q plus 1. Now here B is equal to 4. Clear? But R should be less than, R should be greater than equal to 0. That means it will be 0, it may be 1, it may be 2, it may be 3, it may be 4. No, sir. Not 4 because B is 4 here. B equal to 4. It should be less than 4. So we cannot take 4. Clear, students? So therefore, if it is equal to 4Q plus, instead of 1, if it is 0, it is equal to 4Q. That means is equal to 2 into 2Q. Okay. Now, that means it is even. This is even. Now, if it is 4Q plus, or A is equal to 4Q plus 1. Is there anything common? We can take common? No. Means there is no common, means obviously it has to be odd. Means it is not divisible by 2, as because we can find 2 as common here, means this one is divisible by 2. So that means it's an even number. But it is not divisible by 2, so it has to be an odd number. Again, or A is equal to 4Q plus 2. So here we can see 2 can be taken as common, 2Q plus 1. So children, see, it is divisible by 2 because 2 has been taken common. It is a multiple of 2, means it is divisible by 2 also. It is therefore even. Now, or A is equal to 4Q plus 0 we have taken here, 1 we have taken here, 2 also we have taken here, now 3. Again we can find there is nothing common. So it is again odd, students. So therefore we are asked, show that every positive odd integer, even cross, odd integer is of the form 4q plus 1 or 4q plus 3. Both are odd. So it is proved that every positive odd integer is in the form of 4q plus 1 and 4q plus 3. Got it, students? Copy it down, pause it, copy it down. Let's move on to the next example. So you students, see, here we are having two cases, but we have in the previous example what we learned, 4q plus 1 is an odd integer and 4q plus 3 is also an odd integer. We have already learned in our previous example. So let us take case 1. Case 1 where let n is equal to 4q plus 1. Therefore, we are given n square minus 1. So, n square minus 1 is equal to 4q plus 1 whole square. In case of this n, we are putting the value 4q plus 1 and then square. This minus 1. So, equals to a plus b whole square. A plus b whole square means a square plus 2ab plus b square. So 16q square plus 2 fours are 8q plus 1. Open the bracket now because squaring has been done. Now minus 1. Cancel. Equals to 16q square plus 8q. Now we can see that we can take 8 as common, 8q as common. 8q remains 2q plus 1. So 8 2 is 16q square plus 8q 1 is 8q. So 8q is common. Now what was our question? If n is an odd positive integer, n is an odd positive integer, that means 4q plus 1 is taken as odd positive integer n. They are telling in the question n. But we are taking the value of n as 4q plus 1 because we know that 4q plus 1 formation is always odd. That we proved in our previous example. So n is equal to 4q plus 1. This we already know. So 4q plus 1 as n. Now put the value of n square minus 1 is divisible by 8. So n square minus 1 we found, and see outside it is 8. That means if it is divisible by 8. The total thing is divisible by 8. So in case of 4q plus 1, it is divisible by 8. Even let us take another odd number, that is case 2, where again let us take n is equal to 4q plus 3. Why sir? Another one you are taking. Once you have already proved it is divisible by 8. Why? In order to make our logic confirmed by taking two examples. One example is enough, but it's better to have two examples. Now see. Now therefore n square minus 1 is equal to 4q plus 3 whole square. In place of n square, n's value is 4q plus 3. 4q plus 3 square minus 1. Minus 1. So equals to 4 4 is 16q square plus 2 4s are 8 3s are 24q plus 9. Then minus 9. Minus 1. So that comes to 16q square plus 24q plus 8. Again we can see, we can take 8 as common. 2q square plus 3q plus 1. So see, it was a binomial inside, now it is a trinomial or a polynomial inside, which is again divisible by 8. So it is proved that if n is an odd positive integer, n square minus 1 is divisible by 8. Okay? So hence you will write down at the end as conclusion in the previous examples also. Hence, if n is an odd positive integer, show that it is a positive integer, then n square minus 1 is divisible by 8. This was supposed to be shown. Write down. They are asking for show that. Write down shown. Clear, students? I hope you could understand. After this, I'll try to give you questions in your WhatsApp groups. You will please solve the questions. If you have any problem, please contact me. Send me the questions. Take the image of the question or write down on a page. Take the picture and send it to me. I'll solve it and I'll send it to you. Don't worry. Okay? And don't be in a panic. I'm always there. We teachers are always there. During this lockdown period, we all teachers are here in this side of the camera to help you all, so that you on the other side of the camera are getting proper academic trainings. Okay? Good night. Stay at home. Stay safe. Don't go out of your houses. Okay? And please don't forget to press the subscribe button. Bye. Good night.